Hello everyone, very good evening. So today we are going to start with current electricity. Are you all excited for this chapter? I mean, we have lot to do here, but still the chapter is not that difficult. I mean, difficult chapter we have already crossed. That was your electrostat because in that chapter we had to study a lot. Not difficult because concept was difficult to deliver, not at all, but difficulty in terms of there was so much to read. ठीक है जैसे in the capacitor we were not having that much to read. We just revolved around what is capacitor. We defined certain variable things. We did some questions and it ended in 4 lectures, right? In electrostat we it took us some 11 lectures. ठीक है in normal classes, the classes that will get started after the month of I mean in the month of July that will start, you won't be getting this much of time. Okay. So this is the period when we can be a little slower and we can learn topics more in a more better way. Then also, I mean, we will be teaching in such a way that you will be getting the things, but in this 1 month left, we really have lots of time. So we can slow down also, we can do things properly, more properly, I would say. So now we are going to start with current electricity, the chapter that you must have studied in class 12. Basics you must have studied. You must have seen something of this sort. This is called register, right? You must have talked about Ohm's law. है ना शायद this was in class 10th, है ना? Basic. I don't know if it was there or not. Maybe because it has been so long when I was in class 10th, I couldn't remember it. Maybe it was there. But even if this was not there, one common thing you must have already studied, that is how we define current. Okay? So in class 12th, definitely we are going to extend our understanding. We are going to dive more deeper. We are going to learn more of the concepts. So we will be starting with the basic, but we will first learn what is current, what is Ohm's law, what is resistance, how we calculate it, how resistance depends on temperature, and what is this power thing. Okay. So for today's class, I have kept these things in focus. Let's start with it. Done it. So what is current? Basically, current is rate of flow of charge. So through any cross section, if net amount of charge is flowing in certain interval of time, then we will say that current is flowing. Current we indicate generally by letter I, capital I, and this letter and this current here we can write simply equal to rate of flow of charge. Okay, so let's say there is this conductor, and when current will flow, when current flows, I mean basic definition अगर आप देखो तो definition is this rate of flow of charge. But when current will flow, current will only flow when potential difference is applied across the conductor. And that is why we say if we are connecting it with a battery, then current flows. We talk like this, right? Why we say this? Yes, Kiran. Because of potential, है ना? Because in electrostat also we have learned if there is potential difference, charge ka flow will be there. And flow of charge is what? It is basically current. Done it? So here, if we are connecting this conductor to the battery, what will happen? This end will get positive charge. This end will get negative, not charge. Sorry, this end will get positive potential. This end will get negative potential. Okay, such that there is potential difference. How much? Potential difference is V plus minus V minus. So I will explain here how the charge flows actually. So that I'm going to explain. अब आप लोग मुझे ये बताओ because I have already taught you electrostat. I just want to understand what will be the direction of electric field here inside the conductor. Because we are not talking about electrostat. Electrostat में हमने क्या पढ़ा था? Charge, electro means charge, stat means rest. So we were learning basically charges in rest. Now we are learning current, where charge is moving. Okay? And that charge will move because of electric field getting applied. Okay, so here I just want to know what is the what is the direction of electric field here on the surface of conductor. Let's talk about that. Direction क्या होगा? Positive to negative. Hetal, naam is this. Yes, that's beautiful name. If you get time, let me know what is the meaning of your name. I would love to know. Chalo. So what will be the direction of current? Will be from positive to negative. Why? Because we have learned direction of electric field is in the direction in which potential decreases the maximum. So potential is decreasing in this direction, and hence electric field is in this sense. So what was the status of this conductor before battery was connected? Okay, so before battery was connected, our conductor was like this. Conductor has what? It has free charges, right? So it has free electron and not proton, I should say. Let's talk about in this term, because free protons, it seems very awkward. Let's say there is some positive charge free and some negative charge free. Okay, so conductor is what? Conductor is something that has free positive and negative charge. Now when this thing is not connected, battery is not connected, what is the situation of these free charges? What will be the situation? You have studied what? Thermodynamics. And in thermodynamics, you have studied kinetic theory of gases. And in kinetic theory of gases, you all have studied what is the energy of atom, right? At any temperature T. If I talk about monoatomic, then it is 3 by 2 kT. If I talk about the single atom, T is what? Temperature in Kelvin. You already know this, okay? I have taught it in detail actually when you were in class 11. So temperature is in Kelvin. Now, if you write here, yes, Kiran, very good. So if you write, if you just hold the conductor at room temperature, temperature value will be how much? It will be 290. Sorry, yes, 298 Kelvin, right? And if temperature is 298 Kelvin, there will be energy of each atom. And if each atom has certain energy, these free mobile charges are energetic. Okay? So because of that energy, they will move randomly. So what is the status of these free charges? They are moving randomly. There's so many charges, all are moving randomly. And since they are moving randomly, we cannot say that through any cross section of the conductor, net amount of charges flowing. It seems like whatever is crossing to the left hand side, almost same amount of that is crossing to the right hand side. So there is no net flow of charge. For net flow of charge, we somehow need to destroy this randomness. And how we can bring this free mobile charges in discipline into how we can destroy this randomness by giving it some external force. So here that force will get applied by the battery. So all positive charge will start moving in this direction, in the direction of electric field, and all negative charge will start moving in this direction, that is opposite to the direction of electric field. And hence through any cross section, if you check, there is certain amount of positive charge crossing in this sense and certain amount of negative charge flowing in this sense. So net crossing of charge is happening. अभी तुम सोच रहे होगे कि मैम जितना पॉजिटिव जा रहा है उतना नेगेटिव जा रहा है, आप कैंसिल कर दो. नहीं, because that is not how we define current. We will come to the that thing in the next slide. So अभी मैं ये समझाना चाह रही थी, current is what? Net flow of charge. And when we will achieve this net flow of charge, when we supply or when we connect our conductor to a battery, then we will start getting this. Okay, coming back to this, what is the direction of current? Current direction is in the direction in which positive charge move. Okay, so just now I told you through any cross section, certain amount of positive charge will cross and certain amount of negative charge will cross. So what is the value of current here? Current ka direction is in which direction? In the direction positive charge flows. So current direction is this, and current direction is opposite to the direction of negative charge flow. That is because of this negative charge also, current direction will be in this sense. So overall, because of positive mobile charges and negative mobile charges crossing a particular cross section, there will be current. Okay, and current because of positive and negative charge will get added, and hence we are getting net current. Done it? So direction of current is what? It is in the direction of motion of positive charge, and if negative charge is moving, then current direction will be opposite to that. Now we calculated two things, that is direction and magnitude. Sri Hari, that is taken by convention. ठीक है, जैसे हमने कन्वेंशन में ले लिया है ना कि ये तुम्हारा एक्स एक्सिस है, ये वाई एक्सिस है, ये जेड एक्सिस, दिस इज जस्ट कन्वेंशन, राइट? सिमिलरली वी हैव टेकन इट, वी हैव अज्यूम्ड इट to make the study, I mean, to establish a pattern in the study, we have taken the direction of current to be in the direction of motion of positive charges. ठीक है, तो जिधर पॉजिटिव चार्ज बहता बहता है उधर ही हम किस चीज को मानते हैं? करंट को मानते हैं, और जिधर नेगेटिव चार्ज मूव कर रहा है ऑपोजिट टू दैट इज टेकन एज द डायरेक्शन ऑफ करंट. सो दिस इज बाय कन्वेंशन, आई वुड से. ठीक है, जैसे कन्वेंशन तुमने रे ऑप्टिक्स में भी पढ़ा होगा, मिरर फॉर्मूला 1/v + 1/u = 1/f. When you apply the sign convention, you have studied, right? In the direction of incident light, we take direction to be positive, and opposite to the direction of light, we consider direction to be negative. So here also this is convention, simple. Okay, चलो. Now let's move ahead. अभी अभी हमने क्या पढ़ा? हमने दो चीजें पढ़ा. हमने पढ़ा करंट का वैल्यू. So current value is how much? Delta Q by delta T, where delta T tends to 0. I mean, for very small interval of time, we are checking how much charge is crossing the cross section. So magnitude we talked about. Also we talked about direction. Two things. So is it like current is a vector quantity? क्या होगा बताओ? करंट का डायरेक्शन क्या लगता है तुम्हें? What do you think? Sorry, not current का डायरेक्शन. करंट इज a scalar और वेक्टर. कुछ भी सजेशन दो तुम लोग. ओके श्रीहरि, ठीक है, बट इसके पास तो डायरेक्शन है. रेडमी, ये कैसा नाम है बताओ? यू शुड, आई मीन, रीनेम योरसेल्फ. रंजू. अब देखो रेडमी बुलाने में कितना बुरा लग रहा है, सीरियसली. यू हैव अ नेम, राइट? सो जस्ट आई मीन चेंज द नेम हियर. किरण. यस. श्रीहरि, ओके. Yes. So actually it seems like current has both magnitude and direction. It seems like it is vector in first look, but it's not a vector. It is a scalar quantity. Okay. And why? Because for anything to be vector, there are certain conditions which needs to be fulfilled. First one is that it has a magnitude. Second, it has direction. And very third thing, very important, it should follow the parallelogram law of addition. ठीक है, so when you are adding current, you should be adding it by the method of parallelogram law of addition that we have studied in vector, right? So law of addition को follow करना चाहिए, but current doesn't follow the law of addition. It simply gets added the way we add scalar. So this is not a vector quantity. This is what? Scalar quantity. Next thing, what is the unit of current? If you talk about its unit, it is ampere. ठीक है, so ampere is SI unit. Basically it gets indicated by letter A. Okay, yes Srihari, correct. So that is ampere, A. और यहाँ से ही we can talk about what will be the dimension of charge. I को क्या लिख रहे हो आप? डेल्टा Q by डेल्टा T. So डेल्टा Q का डायमेंशन क्या होगा? करंट का डायमेंशन A, टाइम का डायमेंशन T. So this is the dimension of charge. From here we can write that. Now let's come back to this law, that is Ohm's law. Ohm's law क्या कहता है? The voltage across a conductor is directly proportional to the current flowing through it, as long as temperature and other physical conditions remains constant. So if you have a conductor, what you're doing, you're connecting it with a battery such that potential difference will exist across the ends of conductor. Let's say it has positive potential, it has negative, and potential difference across it is V, equal to the potential difference of this battery. Why? Because there is only one device here on which potential can drop, right? हमें अब तक इतना तो पता है कि ड्रॉप का मतलब क्या होता है, नॉल, ठीक है, बिकॉज यू पीपल हैव फॉलोड द क्लास, ठीक है. Now according to Ohm's law, if we are doing this thing, or if we have a conductor connected with a battery in an environment where temperature is remaining constant and also other physical parameters like let's say pressure we are also keeping as constant, okay, so everything is constant like that, कहने का मतलब environment will not affect how current is flowing in the conductor, ठीक है. So if that is true, then Ohm said that potential difference is directly proportional to current flowing. Okay, that was the law, and V is equal to this proportionality constant was equal to I is equal to R. Okay, and thus we got V equal to IR. Here V is what? V is not potential; it's potential difference. Okay, so potential difference across the conductor. Then this is your Ohm's law. Now what is the graph of Ohm's law? If you draw graph, क्या होता है Ohm's law का graph? क्या होगा? A graph of voltage and current. So if you are increasing, I mean V equal to क्या आया? IR. So I equal to आप क्या लिखोगे? V by R. I को मैंने y axis पे draw किया है, so इसको y लिख लो. V को x axis पे draw किया है, 1 by R x. So graph looks like y equal to mx. And the graph of y equal to mx is what? Yes, Srihari. That's great. So graph of y equal to mx is what? A straight line with no y-intercept. It means it will pass through the origin. Okay? Because general equation of a straight line is y equal to mx plus c, where c is the y-intercept. In this case, if m is positive, then we will draw a graph like this. It will have certain y-intercept. If c is 0, this graph will pass through origin because this is 0. This is C. This is 0. Okay? So this is the graph. Please, everybody, learn how to draw the graph of a straight line and parabolic graph. That is y equal to kx square का graph. ऐसे graphs ना तुम्हें सीखने चाहिए. These two graphs are very important when it comes to solving question in physics. Straight line and parabolic. दो चीजें तुम्हें clear होना चाहिए. Now there is limitation of Ohm's law. Limitation is that V equal to IR formula we cannot apply to all sort of devices. ठीक है? So कौन से devices में नहीं लगा सकते? In the class 12th, when I or somebody else will be teaching you modern physics, then in modern physics you will encounter devices like diode. ठीक है? You will learn Zener diode, photodiode. So all these diode, graph of current versus voltage, either it will look like this in forward bias. Again, you don't have to worry about what is forward bias. This we will learn in semiconductor, and in reverse bias it looks like this. So definitely this is not a straight line. And if I versus V graph is not a straight line, means it is not obeying what? Not obeying Ohm's law. So if somebody asks you, is Ohm's law an universal law? No. Everywhere it won't get applied because there are certain devices where velocity, this is potential. Potential is not directly proportional to I. Okay? So these are the limitations. Okay? Finding resistance. Now how we find the resistance? अब देखो resistance को ना layman term में अगर तुम्हें समझना है, just try understanding. There is this some dome sort of thing. Suppose you have gone to some temples or to some historical site or something. There is so much crowd. Let's say you went there on Sunday. There's so many people, and this is the dome. Okay? So, this traffic of people into this temple or this historical place will get more easy when if area of this cross section is large, ठीक है? So each of traffic, I mean each of flow of people, ऐसे समझते हैं यहाँ से. What you will write here, ease of flow of people will be what? Will be directly proportional to A. ठीक है? Ease is directly proportional to A, and if I mean, if they don't have to travel to the longer distance, let's say the historical site is here only. Okay? So if they have to travel to short distance, it will be more easier, right? Traffic jam will be less, because if you have to travel to the longer distances, there will be more jam, definitely. So again, each of flow of people will be what? Directly proportional to 1 by length. ठीक है? समझ रहे हो? So overall each of flow क्या होगा? each of flow overall क्या दिख रहा है तुम्हें? A by L से directly proportional दिख रहा है. And if I talk about the resistance in flow, if I talk about resistance in flow, that is just the opposite of each of flow. So if I talk about resistance in the flow, sorry, this is not the right statement. Resistance in the flow, then this will be directly proportional to L by A, because longer the length, more the resistance, smaller the area of cross section, more the resistance. Okay, so sort of we are able to see that this resistance thing is what? This resistance thing is directly proportional to length. This resistance thing is inversely proportional to area of cross section. And this resistance will be equal to some constant. Here proportionality constant gets indicated by rho, which is called resistivity, L by A. So rho is what? Rho is your resistivity. Okay? This is what? Resistivity. So this is how we define resistance. When current is flowing through this cross section, I mean, in the flow of current, there will be more resistance if area of cross section is less. So resistance is inversely proportional to area of cross section, and to the length directly proportional. Done it? So this is your resistance. Resistance का अगर SI unit लिखना है तो resistance का SI unit क्या होता है? If you talk about unit, we write it in terms of ohm. ठीक है? Indicated by letter this one. This is this. Okay. Let's understand further things. So let's say here this is the area of cross section A, and here this is the length, and let's say potential difference is maintained across this cross section. Then one is positive, another has to be lower than this, then only current flow will happen, because there should be potential difference, right? Let's say this is negative, current will flow like this. So in which cross section current is entering? In this cross section. Along which length current is traveling? In this length. And hence resistance को आप क्या लिखोगे? Rho L by A. ठीक है? Let's take another case. Let's say here what we are doing is, I am maintaining this end of the conductor at potential plus, and this end of the conductor at potential minus. ठीक है? And this is a cylindrical conductor. Let's say this is a cylindrical conductor. Its radius of cross section, this cross section is R. Length of this cylinder is L. How you will be writing resistance ka value? Everyone think and try. Any idea? Anybody? R is equal to एरिया के टर्म में लिखोगे ना किरण? देखो मैंने क्या बताया, रेजिस्टेंस को क्या लिखते हैं? रो एल बाई ए. एल इज व्हाट? द लेंथ अलोंग विच करंट विल फ्लो. हियर इफ दिस इज मेंटेन्ड एट पॉजिटिव पोटेंशियल, this is maintained at negative potential, you can clearly see here electric field direction is this. So in this direction charge will flow, so current will flow like this from high potential to low potential. This is the direction of current, right? So along which length current is flowing? Along this length. And this length will be equal to how much? 2r. Okay. So you will write here rho into length is 2r. And what is the area of cross section? Current enter kahan kar raha hai? Isko. And where the current is starting from this cross section, entering here, right? So what is the area of cross section here? Batao. Yes. क्या होगा anybody?
4/3 pi r cube.
That is volume of a sphere, right? What is the curved surface area of cylinder? You can say roughly, I mean, through curved surface area, current is entering and then leaving through the another curved surface area. So basically you will write here this wala area, and this curved surface area, roughly we can write it like 2 pi r. So just for the sake of understanding, I'm telling you how we write rho. Yes, Hetal. That's correct. ओके ठीक है. सो मेरा मेरा ये एग्जांपल लेने का सिंपल मतलब ये था कि व्हेन यू गेट द फॉर्मूला रो एल बाई ए, what is the meaning of this L and what is the meaning of this A? So A is the cross section in which current is entering. L is the length along which current is traveling. These two things we have to keep in our head. Let's start with this question. एक question करेंगे हम. This is a good question we will be doing. After that we will move ahead. चलो, everyone take your time, do it and let me know. इंटरेस्टिंग क्वेश्चन है. तुम लोग ट्राई करो, क्वेश्चंस ड्रॉ करो, निकालने की कोशिश करो, मजा आएगा. तो राइट. Physics is really exciting if it starts happening, and you have to reach to the phase where things start happening. So you need to do more of practice. And this is the first question we are going to practice in current electricity. So let's get invested. Do it. देखो, इंटीग्रेशन डिफरेंशिएशन बहुत इंपॉर्टेंट है. whoever is getting problem in integration and differentiation, I am telling you, please do practice this. Otherwise, what will happen, because of these two small things, you will get frustrated in the whole picture. So please practice this. Anybody, anyone, I'm telling you. These two things are really backbone of the calculation of good questions. It is everywhere. Okay? So you should be starting with this. You should be doing it. Also, there is foundation batch running for class 11th this time. And in foundation batch, teachers basically teach basic mathematics because that is helpful in physics. So they're teaching already. Last time you were taught those topics: integration, differentiation, basic mathematics. Should be clear. ठीक है, चलो एक काम करते हैं, क्वेश्चन को समझते हैं. क्वेश्चन है क्या? Space between two concentric conducting sphere of radius A and B. So let's take a sphere of, first sphere is of radius A, then there is a sphere of radius B. So this is A, this is B. And a space between these two concentric sphere is filled with a medium of resistivity rho. So this portion completely is filled with a media of resistivity rho. The resistance between the two spheres will be what? We have to calculate resistance between two spheres. So basically, across this and this end, we have to calculate resistance. Because in this space only resistivity, that material is present. Because of that material, there is resistance in this system. So we need to calculate resistance because of this material of resistivity rho getting filled in this space. Okay? Whenever you are asked to calculate resistance across 2 points, here across this point A and B, we are asked to calculate R equivalent, right? Or resistance. Done it? Across A and B. Are you getting me? Because, I mean, this material starts getting filled with this lining and it ends at this lining. So basically, resistance of this whole space we have to calculate. So from A to B, so we have to calculate what if current starts flowing from this to this, from this to this, then what will be the resistance that it will experience on the way? This is what we are asked to calculate. अब तुम सोचो यहाँ से what will happen? Let's say this is point A, this is point B. Let's say we are maintaining A at positive potential, B at negative potential. So definitely current will flow from A to B. I mean, in all, like this way current will go. Concentrically outward it will go. Radially outward, I should say. It will go like this. Now, if you look carefully here, ध्यान से देखना, here current is entering this big area. And if you talk about current entering here, then it is entering this area. So as current is going more outward, it is crossing through a greater surface area, I would say, because you are starting from A यहाँ से start हुआ, just above it will encounter this surface area. Through this surface area, current has to pass, right? And just above it, again another surface. Again, this is a little more than that of previous one, and this will continue increasing up to the point P. Okay? So what I'm trying to tell you is, when we write resistance is equal to rho L by A, we can put this formula and calculate resistance only if A is a constant, right? A is a constant. Here A is not constant. A is not constant. देखो यहाँ से जो भी करंट गया सारे this length they are crossing. But as it is moving outward, area of cross section is changing. The area through which it is crossing is changing. So area here is variable. And when you get anything variable in the formula of anything, and you have to calculate that thing, here that thing is resistance, then you need to apply integration. Or I mean integration, yes. ठीक है, सो यहाँ पे तुम्हें सबसे पहले क्या आइडेंटिफाई करना था? दिस एरिया इज वेरिएबल. नाउ हाउ वी विल डू दिस क्वेश्चन? तो देखो, जब भी यू इनकाउंटर एनीथिंग टू बी वेरिएबल, वी cannot calculate the total resistance in one go by simply putting the value. We cannot, right? So what we will do in that case? In that case, we will calculate a small resistance, dr. ठीक है? So a small resistance हम कैसे calculate करेंगे? For that, we will take, let's say, when it is crossing this dr length, when this is crossing this dr length, then for this dr length, almost area of cross section is how much? Let's say this dr length is at a radius r. So if current is crossing through this small length dr, area is for all current 4 pi r square. Done it? So for this small length dr, we can calculate area resistance like small resistance like rho L. L is how much? Dr length. Area is how much? 4 pi r square. This one we can write or not. अब तुम लोग मुझे यहाँ से बताओ. Okay, Thanush, very good. I got one answer here from one person. It's great. चलो, anybody tell me dr को ऐसे लिख सकते हैं कि नहीं? If you have understood up to this, things have really got easier for us. How many of you agree with this? Because in electrostat also we have done lots of calculation with integration, right? and every time we calculated small electric field, if you remember. So here also we will calculate for small resistance, for certain length, for very small length, because their area of cross section for dr length, I mean, for if you consider this whole length, area of cross section is not constant. But if you consider a very small length, we can assume that area is what? Constant. Okay, Kiran. Okay, okay. देखते, क्योंकि two people has given me the answer and both are different. So let's check. dr सबको I hope सबको समझ में आ गया है, क्योंकि nobody is asking. So question is like this. ठीक है, this is how much A and this is how much B. And let's calculate the small resistance. So for this dr length we are calculating. इस dr length के लिए calculation किया हमने. So small resistance dr is equal to how much? Rho. This small length, let's say this small length is dr and its radius is r. So rho dr by 4 pi r square. Now we need to calculate the total resistance here. So dr को आप integrate कर दो. Rho by 4 pi, constant को integration sign से बाहर लेकर आओ, dr by r square. And if you want to calculate the whole resistance, such sort of a strip will vary from where to where? From here to here. From here to here means r will vary from A to where? A to B, right? So here r will vary from A to B, right? Like this. Now you solve it. dr का integration क्या होगा? R होगा. And this is rho by 4 pi. And here you will write what? dr by r square का integration क्या होगा? -1 by r. ठीक है? And this is A, this is B. So rho by 4 pi. माइनस को बाहर ले लो. Put in the values. R का वैल्यू पहले B रखो आप. माइनस R का वैल्यू A रखो. This. ठीक है? So what is going to be the answer? Rho by 4 pi. ठीक है? माइनस साइन अगर ऐसे करते 1 by A minus 1 by B. So what will be the answer? Answer will be your B. Srihari, yes. That's correct. Thanush, you were correct. Kiran, you got some, you got, I mean, maybe you did some mistake with the calculation. ठीक है? Integration मैंने कैसे किया है? So again, I will give you the formula. X and dx का integration क्या होता है? X n plus 1 by n plus 1. So here x is what? R and power is what? -2. अगर 1 by r square है ना, उसको ऊपर ले जाओगे, power is -2. It is this. So -2 plus 1, r to the power -1, that is 1 by r. And -2 plus 1 नीचे लिखोगे, minus sign, and hence I have written it like this. So correct answer is which one? B. चलो, हमने बहुत ही अच्छी चीज सीखी. We have got it. Now this is going to be very interesting. Velocity of free charge inside conductor. ठीक है? So conceptually now we are sound enough. So मैंने तुम लोगों को initial में ही बताया. If conductor is at room temperature, then at room temperature free charges are randomly oriented, right? Free charges are randomly oriented. Done it? And the moment after which, I mean, let's say at t equal to 0, we switched on the electric field. At t equal to 0, what we did? We switched on electric field we supplied. Then what will happen? Current will start flowing and it will start getting into discipline. Okay? So if we talk about the, I mean, initially when there was no electric field, these free charges were having some velocity. Okay? After the electric field is supplied, these free charges are also having certain velocity because they are moving from positive end to the negative end. So they are having velocity. Let's apply first equation of motion. You know, V equal to U plus AT. Okay? है ना? So if we talk about any single particle, let's talk about it. So, I mean, initially, if we say how much velocity it is having, this is a very random question, very absurd question, something that we cannot answer easily. Because when we say things are moving randomly, it can have any velocity in any direction. क्योंकि हमने thermodynamic theory of gases में Maxwell curve भी पढ़ा है. And Maxwell curve में हमने देखा है Maxwellian tail. अगर तुम लोगों को कर्व याद हो, मैंने पढ़ाया है क्लास में. This tail has, I mean, molecules with very high energy. So here if they maybe some free mobile charges are having very high velocity. So मैं ये कहना चाह रही हूँ कि randomly if you are picking any atom and if you try to measure its velocity will be random for this one, for this one, for this one. You cannot fix it. ठीक है? So if we talk about instantaneous velocity for any atom, it's very difficult to tell. That is why we will talk about average. ठीक है? So average की अगर मैं बात करूं, suppose करो I am talking about 1 second time, or I am talking about 0.5 second or 0.001 second. कोई भी टाइम ले रही हूं मैं, an average velocity I am trying to calculate. So on the average I can say कि at an instant, if it is directed towards this, another moment maybe it is directed towards this, or maybe like this, or maybe like this. So average velocity when battery is not connected, we can write like what? क्या लिख सकते हैं बताओ? Average velocity when it is not connected with the battery, that is at t equal to 0. क्या होगा? They're randomly oriented. What will be the average velocity? Yes.
Two V1 V2 by V1 plus V2. I got disconnected basically. Sorry. कोई नहीं. Let's say the slide. I was asking average initial velocity कितना हो सकता है बताओ. I was just taking the idea of you people. So maybe I was not audible at that time. That is why maybe you people didn't answer. But I know you can do it. Let me know what will be the average initial velocity in the random state. At t equal to 0, these electrons are, or these mobile charges are randomly oriented. What will be its average velocity? Am I audible, everybody? Anybody? You can unmute yourself and tell me. Yes, ma'am.
Okay, thank you. तो नहीं समझ में आ रहा है तो चलो मैं एक्सप्लेन करती हूँ. Average velocity will be 0 because they are randomly oriented. If they are randomly oriented means this particular atom in particular interval of time will have velocity in very different directions. So if you add all these random directions velocities, you will be getting 0, right? So u average initially is how much? It is 0. So what will be v average? We are talking about now average because instantaneous velocity से deal नहीं कर सकते. Instantaneous velocity, if we go on to calculate, we will get different for different atoms. That is why we are dealing with average thing. Okay? So because in the average, those changes will get accommodated, right? Those unevenness will get cancelled out. That is why we do average, right? So we are doing average. V average का value क्या हो जाएगा? This is U average is 0. So I will write here this plus A T average. ठीक है? And V average will be equal to how much? U average is 0. What will be the acceleration of this mobile charges? Electric field getting supplied is E, let's say. Let's say charge of each mobile carrier is Q. Then force acting is how much? QE. And acceleration is what? QE by M, where M is the mass of that charge carrier. Okay? So force by mass, that will give you acceleration. Acceleration is this. And T average is called tau. What is this T average? I mean, if you have supplied electric field, अगर तुमने electric field supply किया, any mobile charge carrier will start moving in certain discipline. Let's talk about there are only positive mobile charges. So all are moving in this direction. Okay? And they're so closely spaced. Collision can occur between one atom and another, right? So time between two collision is taken as tau. ठीक है क्योंकि in the time in which collision is not happening, velocity will not change, it will remain the same. So basically T average कहने का मतलब क्या है? This is the average time in which molecules or free charge carrier will collide with each other. ठीक है? So this is your tau, and V average here is equal to how much? It is equal to QE by M tau. ठीक है? So this V average is called drift velocity. This is called drift velocity. So drift का मतलब क्या होता है? Drift is an English word and it has a meaning of something started moving in certain directions with certain constant velocity. Drifting. ठीक है? So V drift is QE by M tau, where tau is what? Tau is the time of relaxation. So what things we studied? One is your relaxation time. This is it is time between two consecutive collision of electrons in a conductor when current is flowing. Okay? So this is your tau. Tau will be direct function of temperature. क्यों? क्योंकि if temperature is higher, let's say this conductor is getting heated. Okay? So when you are heating the conductor, those free charge carrier will get heated. They will gain more energy, and more energy means they will collide more. And if they are colliding more means between two collision, there is small time interval. Okay? So tau, that is relaxation time, is the function of temperature. How it is related? Directly or inversely होगा. मैंने जो भी explain किया उसके according, if temperature is increasing, tau will decrease. So I should write it 1 by temperature, right? Because just now I said, if we are increasing the temperature, randomness has more chance to, I mean, entropy will increase, randomness will increase, and hence time between two collision will decrease. So tau is inversely proportional to temperature. Then we studied one more thing, that is your drift velocity. It is the average velocity attained by charged particles in a material due to an electric field. So what we studied is, if there is a conductor, there is free charge carrier. Let's say it started at t equal to 0 time. Here it will again collide with another particle. After how much time? After time tau. Okay? So here its velocity, initial velocity, that is initial average velocity, we take this as a 0. So final average velocity, or the average velocity after which we switched on the electric field, it will be equal to U average plus AT. And that is why we wrote here V drift, which is average velocity, equal to QE by M tau. So this thing we did. Now there is a very famous thing that comes, NEET में बहुत बार आया है, drift velocity is average velocity or instantaneous velocity. So this is an average velocity. This is not instantaneous velocity, because calculating instantaneous velocity is very difficult. It cannot be done simply. Okay? Now we will learn current at microscopic level. This is also very interesting. Let's say current को अभी तक हमने कैसे पढ़ा? Current को हमने निकाला Ohm's law से. So current is equal to V by R. Potential difference by resistance. Let's say this is maintained at positive potential and this is maintained at negative potential. Charge will start flowing in this direction. So करंट को आप क्या लिखते हो? करंट को लिखते हो डेल्टा क्यू बाई डेल्टा टी। ठीक है, चलो नाउ लेट्स डू वन मोर थिंग। जैसे देखो, अभी तक हमने जो ये, अब यू मस्ट बी थिंकिंग व्हाई वी आर कैलकुलेटिंग करंट अगेन। So I equal to V by R, we calculated this on macroscopic level. How? हमें ये दिया हुआ था पोटेंशियल डिफरेंस अक्रॉस द कैपेसिटर इज गिवन V, ठीक है, रेजिस्टेंस इज R, we calculated current. But what if we have to calculate current at microscopic level? कहने का मतलब, let's say it is given that number of free charge carrier per unit volume is given, that is N. Let's say this is given. Charge contained in each free charge carrier will be E, that is charge on one electron. Let's say it is given like that. And let's say this is area of cross section is given as A, through which current is entering. And it is asked that calculate current in terms of N, E, area, its drift velocity. So basically now what we are doing, we are going to calculate current in terms of the parameters of each individual charge carrier. This charge carrier has average velocity V drift. It has a charge of how much? How much value of charge it is having? It is having charge E. Its velocity is V drift. How many charge carriers are there in this? Number of charge carrier per unit volume, that is small n. And in this term, now we have to calculate current. How we will do this? Let's say from here, current started flowing. Okay, so current started flowing from here. Okay, and let's say in delta t time it reached this cross section. In what, how much time it reached this cross section? In delta t time. Done it? So in delta t time, what will happen? Current will go out from this cross section. So how much current has flown in this case in time delta t? कितना current flow हुआ बताओ? So current flown you will be writing as whatever charge has flown from here to here in time delta t. So you will be writing delta q by delta t. Now what will be delta q? Here area of cross section is A. Let's say this length is a very small. Okay? Let's say this length is delta x. Done it? So what is the volume of this region? So volume of this region, if you write volume, how much it is? कितना होगा बताओ? Anybody? What is the volume of this region? You people are not getting me, I guess. Let me erase everything. मैंने ये बोला current is entering here, ठीक है? And then what is happening? It is reaching this cross section. I mean, it is then coming out from this cross section. And in what amount of time this all things happen? In delta t amount of time. So if current is entering here, leaving here, some amount of charge has flown in this region, right? I have said, let's say its thickness is delta x. So I'm asking how much current has flown. So I will say delta q by delta t. This thing I will say, right? Now the task is to calculate delta q because delta t is already given. What more is given? Number of charge per unit volume is given. And this is how much? Small n. What is this small volume? So here is the area A and this is length delta x. So this is area of cross section and this is delta x. So dV is small volume through which current is flowing or charge is flowing in delta t time. Its value is A dx, right? Or A delta x, whatever you write, A delta x, because this is small distance we have taken. So this is the volume. Now in unit volume, how much charge is there? Free charges n. And in A dx volume, how much charge will be there? N A dx और डेल्टा एक्स लिखूं मैं, ठीक है? सो डेल्टा क्यू का वैल्यू आप क्या लिखोगे? एन ए डेल्टा एक्स बाई डेल्टा टी, ठीक है? Now what will be, this is the number of charge flowing, right? What will be the value of charge? So this is the number, value of charge के लिए you will multiply it with E, ठीक है? So now let's write the current A N E delta x by delta t. Delta x by delta t क्या होगा? Velocity. So we have learned of drift velocity. So we can only talk about drift velocity, not instantaneous. On the average, we will talk. So ANEVD, and this is the value of current that you will get on microscopic level. That is, when you are given that number of free charge carrier per unit volume, drift velocity, charge on each carrier, that is equal to electron, and cross sectional area, then we can talk about current flowing, that is equal to ANEVD. This is current at microscopic level. कल के class में we will be moving further with current density, we will learn, and then we will learn another forms of Ohm's law, then series and parallel combination of resistors, we will do some questions, and after that we will move ahead. किसी को यहाँ तक doubt है तो बताओ. Let's take this 2 minutes for doubt. किसी को doubt or any suggestion, anything you want to share, everything is welcome. So you can share your views or whatever. Okay, I feel like you people are getting late, है ना? You want break? Maybe. ठीक है. So एक काम करो, आप लोग अपना ख्याल रखो, चाय चाय पियो, थोड़ा ब्रेक लो, बाहर जाओ, प्लेग्राउंड में जाओ, एंजॉय करो. If time is left, I know, I mean, there is so much discipline in your Navodaya, and that's good for our life actually. We should live under discipline. It's good, but whatever time you get, freshen up yourself, have some snacks or anything, and then again, sit with questions. Do whatever, I mean, read whatever you want to read. I won't say read only physics, also read chemistry, mathematics. But yes, up to this point, I won't say practice question from current. I would say practice so far questions from capacitor and electrostats. ठीक है. कल के क्लास से we will start doing more questions on electricity, क्योंकि I will discuss then what series and parallel combinations, and then we will be more in a good position to do questions from current electricity. ठीक है. तो चलो, thank you everybody for your love and support. I mean, you really sit in the class with so much discipline, I would say. You reply, you give answers, you do things. It's good. It's something I appreciate. So thank you so much for being this much good and kind, and keep on being this good, and also maybe you can become more good. I don't know that, you may be knowing this. Okay, so keep on improving and keep on doing the blast. कल मिलते हैं फिर से. प्रिया, bye bye, tata everyone, bye bye, tata, take care, Sri Hari, thank you, thank you, thank you. चलो, टेंशन किसी को नहीं लेना है, काम सभी को ज्यादा करना है. लेस टेंशन, मोर वर्क. दिस शुड बी द फिलोसफी ऑफ लाइफ. डन है. हेतल, you didn't tell me the meaning of your name. So if you don't know, आज this is your homework. Tomorrow you will come with the meaning of your name and you will let me know. But उससे पहले तो मैं ही सर्च कर लूंगी. ठीक है. चलो, tomorrow I will let you know the meaning of your name. Bye everyone, take care. Bye Kiran, Lakshmi, Sanjana, Simran, everyone, bye bye.